Welcome to our video today. We want to look at this question, a titration question or a paper 3 question together. Let us go together step by step. Thank you for your continued support. You are provided with a solution P of potassium manganate 7, 0.5 molar solution Q of oxalic acid, solution R containing 4.9 grams of ammonium ion 2 sulfate in 250 of water. Like I've always said, it means that this mass 4.9 grams was dissolved to form a solution in 250. So this is not the mass in 1 liter. This is the mass in 250. So it's important to write that this is the mass grams per 250 centimeters cube. This is the mass in 250, right? Yes. You are required to determine the rate of reaction between oxalic acid and the potassium manganate 7. Standardize the solution P. Let us look at procedure 1. Practical is just following instructions and acting on them. The instruction, like here you are told, using a measuring cylinder, place 1 centimeter of solution P into each of the 5 test tubes in a rack. Clean the measuring cylinder and use it to place 19 centimeters of solution Q into the boiling tube. Prepare a water bath by placing about 200 centimeters cube of water into a beaker and start to heat. Place a thermometer into solution Q and place it in the warm water until it attains a temperature of 40 degrees Celsius. Remove the boiling tube from the water bath and place it in a test tube rack. Add the first portion of solution P immediately, and at the same time, start a stopwatch. Record the time taken for solution P to be decolorized in table 1 below. Repeat the procedure at temperatures 50, 60, 70 and this to complete the table. So as you can see, it is a question of rate of reaction. So just follow instructions and you will get it. So let me give you the detail, the time taken. For this one it took 74 seconds. This one took 43, 22, 11 and 10, 7. Time taken in seconds, and then get 1 over t. This is 1 over t. That is seconds. You have to 1. So you take a calculator, you find the reciprocal of all of these numbers. You will find this one will be 0.0135. This one will be 0.0232. This one will be 0.04. This one will be 0.09. This one will be 0.143. So we are required to plot a graph of 1 over t against temperature. So 1 over t, remember it is the rate of reaction. The rate is 1 over t. So we are going to draw 1 over t against temperature. Yes. So let us take our graph. Let us take our graph and draw the graph together. Let us draw the y-axis together. This is the y-axis. Then draw the x-axis. The first thing now, this is temperature. In degrees Celsius. and this one is 1 over t seconds per second. 1 over t. So because our temperature begins at 40, so we can break this graph. We can break it like this, and we start here at 40. 40, 50, 60, 70, 80. This one we will begin at 0, the y-axis. We have 0.01, 0.01. So here will be 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09. Now we are going to turn that to 0.1, 0.1, 1, 0.12, but we stop at that point. Now using our values, when temperature is 40, our reciprocal 1 over t is 0.01. So we are going to take 1 because this cannot affect it. If we round off, it will remain 0.01. So when temperature is 40, our first point is here. When temperature is 50, it is 0.02, 0.02 there. When temperature is 60, the value is 0.04, 0.04 there. When temperature is 70, the value is 0.09, 0.09 is there, is here. And then when temperature is 80, we have 0.1, 0.1, 0.1. So it is also important to know or to remember the appearance of the graph when you are dealing with rate of reactions, because when you are dealing with energy changes, the graphs are different. You should know where you expect a curve, where you expect a straight line. That's something which you must know. So here we are expecting a curve. So we take this curve. We can draw this curve. So draw a smooth curve. A smooth curve going up to that point. And we have our graph. Now let us use our graph. So remember this, you will get all of the marks for the graph. 3 marks for free. From the graph, determine the time taken for the mixture to decolorize at 65 degrees Celsius. So you take your graph and then you 40, 50, 60, so 65 is here. Take a ruler, draw a dotted line to the graph, to the curve, dotted line. Where the dotted line meets the curve, go across to x-axis so that we can, to y-axis, sorry, go across to y-axis. So we can see our time is 0, our reciprocal is 0.052. So from the graph, it is 0.052. Remember, this is equal to 1 over t. So how do you get t? So we want time, not 1 over t. This is 1 over t, but we want time. So you get time. So to get the time, take 1 over this 0.052 Using your calculator, give us the correct answer. So this is 19.23 seconds. So whenever you are told to from the graph, you must show using a dotted lines like this. That's when the person who is going to mark will check whether you used the graph. Next question. How does the rate of reaction between oxalic acid and potassium manganate 7 vary with the temperature? So you realize the rate of reaction increases with increase in temperature. Where did I get this information from? Look at the graph, even this data we have here. When temperature was 40, it took 74 seconds. But what happened when the temperature was 80? It took 7 seconds, meaning the rate of reaction here was very fast, right? So as temperature increases, the rate of reaction increases, and it takes less time for the reaction to come to an end, to reach the end point. Procedure 2. Fill a puree with solution P, pipette 25 centimeters cube of solution R into a conical flask, and titrate with solution P, and titrate the solution P against solution R until a permanent pink color just appears. Record your results in table 2 below and repeat the procedure to fill the table. So I want to give us the value. Let us use 12.9. Our initial is 0.0. That's 12.9. Our initial is 0.0, 12.8. And here it is 12.8, 0.0, 12.9, 12.77. So determine the average of P used. So you get the average 12.9 plus 12.8 plus 12.7 divided by 3. You get 12.8 centimeters cube, and that is the average. Calculate the concentration of solution R in moles per liter. Moles per liter means molarity. Molarity is the number of moles in 1 liter. Therefore, when you are asked to calculate the concentration of a solution in moles per liter, they are simply asking you to calculate molarity. And I have always given you this formula on how to calculate molarity. How do you get molarity? Molarity, that is mass in grams per liter, RFM. So if you have RFM, you have mass in grams per liter, you can calculate molarity simply. So let us go back to what we are provided with and check what was the information provided for R. That R was made or prepared by dissolving 4.9 grams in 250. So the solution is 250, meaning that this is not 1 liter. So we must now calculate the mass in grams per liter, right? So we are going to say 4.9 is in 250. What about 1,000? Now we will get mass in grams per liter in order to use the formula I have given. So let us get mass in grams per liter. We are going to say that 4.9 grams are in 250 centimeters cube. For me to get grams in 1 liter, I will ask 1,000 centimeters cube would contain what mass? 1,000 times 4.9 divided by 250 will give me 19. It will give us 19 0.6 grams per liter. Now we have this. The next thing that we should have is the RFM of R. R is the iron 2 sulfate. Remember, R is this salt, NH4 2 S4 dot Fe S4 dot 6 waters. So the formula already is provided here. Remember, R is here, this is R, and this is the salt, ammonium iron 2 sulfate. So this is what I've just copied. So we have iron is 56, sulfur is 32, oxygen is 16. So you only need to substitute the numbers inside here, and you will find that the RFM of this salt is equal to 392. That is the RFM. Now from the formula, we know that molality equal to mass in grams per liter divided by RFM. That is, molality is equal to, you already this one constant, mass in grams per liter over RFM, and this one is 19.6 divided by 392, and this one gives us 0.05 capital M, standing for molality. Now we have the molality of R. Let us go to find the number of moles of solution R used. How much, what was the volume of R used? You go back to the procedure. Fill the puree with solution P, pipette 25 of solution R. So we have used 25 centimeters cube of solution what? R. But now we know the number of moles in 1000 in 1 liter. This molality is the number of moles in a liter. So we have that 1000 centimeters cube of solution R as this moles, 0.05 moles. The volume used, R used, is 25. So we will ask 25 centimeters cube of solution R used will contain how many moles? Now that one is 25 times 0.05. You divide it by 1000. And this one gives us 0.00125 moles, right? Next question. Given the ionic equation for this reaction will always be given the ionic equation, so you don't need to worry about that. You will always be given the ionic equation. Will always be given the ionic equation. So we have been given the ionic equation of the reaction that took place. But remember, what is R? R was the ammonium iron 2 sulfate. So this one represents R. This one represents P. What was the volume of this used? 25. What was the volume of this used? 12.8. It's important to note that. Now we have the number of moles of the ion, R. We have the number of moles of the ion. We find the number of moles of solution P, which is this. Number of moles of solution, we are going to use the relationship of the mole ratio. Here, the ion is 5, and this is so. If I use R to P, R is 5, and P is 1. The ratio is 5 to 1. But we have the number of moles of R, which is 0.00125. This number of moles, this number of moles of R. So we will ask, if 5 is equal to this, what about 1? If 5 equal to 0.00125, 1 will contain what? So that is 1 times 0.00125 divided by 5. And this one will give us the number of moles of P, 0.00225 moles. So this is the number of moles in P, the volume that was used. What was the volume of P? You go back, determine the average volume of P, and that is 12.8 centimeters cube. That is the volume of P. Determine the concentration of potassium manganate 7 solution P in moles per liter. Concentration in moles per liter. Kindly always remember, when you are asked concentration in moles per liter, simply that one is molarity. Always remember that. So we want to calculate molarity. And remember, what is molarity? Moles in 1,000 centimeters cube. 1,000 centimeters cube equal to 1 liter per liter. Right? But from the previous, we have the number of moles of P. We have the number of moles of P in the volume that was used, 12.8 centimeters cube. So these moles are in 12.8 centimeters cube. So we will ask 1,000, which is 1 liter, will contain how many moles? So we know that 12.8 centimeters cube of solution P contains 0.000025 moles. Because moles, molarity is in 1,000, we will ask what about 1,000 centimeters cube solution P will contain how many moles? Right? So this one will give us 1,000 times 0.0025. You divide it by 12.8, and this one will give us 0.01953 capital M, and that is the molarity of solution P. Qualitative analysis. I want to give you observation and inferences very quickly. You are provided with solid P. Carry out the test below and record your observations and inferences in the table below. Place a half of a spatula full of solid P in a clean dry test tube and heat gently then strongly. What will be observed? A colorless gas condenses on the cooler parts of the test tube, forming a colorless solution or liquid, colorless liquid. A colorless liquid. So a colorless gas is produced, which condense and form a liquid. So if it forms a liquid, it tells you that that salt P contains water of crystallization. So you can simply say that B, it is hydrated salt present. Or you can say that B contains water, that is or. You can use this or this. B contains water of crystallization. Contains water of crystallization. Place the remaining P in a pouring tube. Add 5 centimeters of distilled water. Shake. Divide the solution into 4 portions to the first portion. So divide the solution into 4 portions. Now here, this one is supposed to tell us whether the solid was soluble in water or not. The solid dissolves in water, in distilled water, forming a colorless solution. So it simply means that solid B is a soluble salt. That's what it means in simple terms. In some more complicated terms, we can say, because this solution is a colorless solution, it means the colored ions are not there. And what are the colored ions? It means that copper 2, which is blue, it means copper ion 2 which is green, and ion 3, which is brown, are absent. So these ones are absent. If you don't understand this, use this one, that if it dissolves to form a colorless solution, it means the salt is soluble. You say a soluble salt present. To the first portion, add sodium hydroxide dropwise until in excess. Sodium hydroxide dropwise until in excess. White PPT is formed. A white PPT is formed, which dissolve in excess, forming a colorless solution. I want to remind you here that we need to make observation first. When you put 2 drops, a white precipitate is formed, and then tell us what happens when you put the sodium hydroxide in excess. Did the white precipitate dissolve to form a colorless solution, or it did not? So if it dissolves to form a colorless solution and you are adding sodium hydroxide, then it means this is present. What is that? ZAP. ZAP stands for zinc ions, aluminium ions, and lead ions. Remember, these are amphoteric. They form amphoteric oxides, or we call them amphoteric ions, right? So it means that the zinc, aluminium, lead are present. To the second portion, add 2 drops of dilute sulfuric acid. If you are adding sulfuric acid, remember sulfuric acid is this. It contains the sulfate inside. So if you are adding the sulfate, let us see the observation. A white PPT is formed, or no white PPT is formed. What if a white PPT is formed? If a white PPT is formed, it means inside there could be barium 2 ions, calcium 2 ions, and lead. If a white PPT is formed, right? If no white PPT is formed, it means none of them is present, right? None of them is present. So let me give the observation. The observation here is no white PPT is formed. We are adding sulfuric acid, which forms a white precipitate with barium, calcium, and this one. So we are supposed to write barium 2 positive, calcium 2 positive, and lead 2 positive, absent, right? But in our previous, we didn't have any of these ions. Yes, although they are absent, and that is correct. So they are not there, right? But what was there? Here we said that red is present, but here we have confirmed it is absent. This one is correct. You can write all of them and write all of them are what? Absent. It is accepted. But we don't want, suppose this one are absent, then what could be present? Lead is not present. It's absent. It means that zinc 2 ions, aluminium 3 ions are present. I want to discourage giving absent negative answers, because they usually sometimes are advised to reject negative answers. Therefore, let us write what is there. If these are not there and we add 3 of them, this one is absent, it means these and these are present. Thank you. To the third portion, add ammonia solution. Ammonia solution is usually written ammonium hydroxide. So this is what you will find written in that small capoto. So observation is that white PPT is formed, which is soluble in excess. So it forms a white precipitate drops. When you add in excess, it dissolves to form a colorless solution. Therefore, it means zinc ions are present. It means zinc ions are present. To the fourth portion, add 2 to 3 drops of barium nitrate solution. So we are adding barium. Barium forms white precipitate with sulfate, carbonate, and sulfite. So what was white PPT is formed. So if a white PPT is formed, it means the sulfate, the sulfite, and the carbonate are present, right?